Question 13, Part B. Consider the curve y equals 2x cubed plus 3x squared minus 12x plus 7. Part 1. Find the stationary points of the curve and determine their nature. The function is a cubic polynomial. Now we know this because the highest power is a 3. We call that the degree of the polynomial. Also, the leading coefficient, so that's the number that's multiplying the x that has the highest power, is positive. So I expect the shape of the curve to look something like this. We have a local maximum stationary point here and a local minimum stationary point here. Now this will come in useful in part 2 when we sketch this curve. Now we need to find the stationary points, and the stationary points are points where the gradient of the tangent to the curve is equal to 0. So we need to differentiate y with respect to x, and we get y dash is equal to 6x squared plus 6x minus 12. And we need to solve the equation y dash equals 0. That is 6x squared plus 6x minus 12 equals 0. Now we can divide all terms by 6 to simplify the quadratic equation, and we get x squared plus x minus 2 equals 0. Now the left-hand side factorizes nicely. We have x plus 2 in brackets times x minus 1 in brackets equals 0. So x is equal to negative 2 or positive 1. So stationary points exist where x equals negative 2 and x equals 1. Now we need to determine the nature of those stationary points. And I'm going to use the second derivative, y double dash, to help us determine the nature of those stationary points. So differentiating y dash, so this function here, with respect to x to get the second derivative, we get y double dash is equal to 12x plus 6. Now I'm going to summarize my findings in a table here. So where x is equal to negative 2, the value of the second derivative y double dash is equal to negative 18. So that means that that region of the curve is going to be concave down. So that implies a local maximum stationary point here. And when x is equal to positive 1, the value of the second derivative is positive 18, which means that that region of the curve is going to be concave up, which implies a local minimum stationary point there. And I've written that here. We also need the function values, or the y values, when x is equal to negative 2 and when x is equal to positive 1. So when x is equal to negative 2, by substitution, y is equal to 27. And when x is equal to 1, by substitution, y is equal to 0. Therefore, a local maximum stationary point exists at negative 2, 27, and a local minimum stationary point exists at 1, 0. Part 2. Sketch the curve, labeling the stationary points. Here is a sketch of the curve y equals 2x cubed plus 3x squared minus 12x plus 7. Now the question's worth 2 marks, so it's 1 mark for the correct shape and another mark to correctly label the stationary points as instructed. Now the shape I spoke about in part 1. By noting the type of function that we're dealing with, we know that we're dealing with a cubic polynomial. The degree is 3. Also, the leading coefficient is positive. I'm going to expect a shape similar to this. And here is our local maximum at negative 2, 27, and our local minimum at 1, 0. I've also included the y-intercept, even though the question didn't ask for it. It's an easy enough value to find. If we let x equal 0 here, here, and here, we get y is equal to 7. Now it's also important to draw the graph fairly large, so usually 1/3 of an A4 page. Also, draw the axes with a ruler. Try and make the y-axis and the x-axis at right angles to each other. And also label the origin, the x-axis, and the y-axis as good practice. Part 3. Hence or otherwise, find the values of x for which dy dx is positive. From the graph that we sketched in part 2, we're identifying intervals of x where the gradient of the tangent to the curve is positive. Now this occurs where values of x are less than negative 2 and also values of x greater than positive 1. Between negative 2 and positive 1, not including the endpoints, the gradient of the tangent to any point on the curve between those two x values is going to be negative. So we can summarize that result as such. So we can say that dy dx is going to be greater than 0 in the interval x less than negative 2 or x greater than 1. And we can express that in interval notation as open round bracket negative infinity comma negative 2 close round bracket union open round bracket 1 comma infinity close round bracket.